now we're ready to translate sine and cosine functions. And jot down this information and we'll go through and do some examples. So we've had these parent functions previously where we had y equals a sine of bx and y equals a sine cosine of bx. And what we're going to basically be doing now is translating them. We're going to slide them left and right, up and down. And so when we talk about shifting a graph left and right, that is called a phase shift. So a phase shift is a horizontal translation, and a vertical shift is going to be a vertical translation. And I have that labeled down here. So here are our parent functions, and we're going to make them slide. And notice that when we make this slide, this h, x minus h being substituted for x, there's definitely a necessity to have those parentheses around that x minus h. So make sure you write that down properly. And then this plus k is tagged on at the end. These k's are going to affect up and down. The h is going to affect left and right. And you must have the b factored out in order to see that translation. So as has been the case all along, the absolute value of a will be our amplitude, and that's either going to vertically stretch or shrink our graph. Our period for both the sine and the cosine function will be 2 pi divided by b. Nothing new, nothing different. The only thing we're doing now differently is we are making some shifts left and right, which is our phase shift or our horizontal shift, and our k is our vertical shift. So this is going up and down, this is going left and right. And so if we look at these two equations, and we want to look at what is happening to the graph, notice that we just want to find out how this is translating in terms of words. And this acts very similarly if you think a flashback to parabolas. This is going to make our graph translate or shift 2 units to the, yes, to the right. Or it phase shifts it 2 to the right. And this is going to make our sine function shift 3 units to the left. So it will phase shift it 3 units to the left. If we tagged on beyond here something like a plus 7 or something like that, that would affect the graph vertically and make it shift up 7. Okay, so let's get right to sketching a graph. Okay, and we kind of go like a little machine on these. So we're going to start with sketching the graph of y equals sine of x minus pi over 2. And we're going from 0 to 3 pi. So we know that our amplitude is 1. We know that the period is 2 pi over b, which is just 2 pi. We have critical points every 1/4 of the period, every 2 pi over 4, every pi over 2. We have a phase shift. And a phase shift, this is going to be a phase shift of pi over 2, and yes, it is going right. You don't need to write that down normally. If this is a positive phase shift, it will go right. Now, we don't have a vertical shift, so our graph will just be centered around the x-axis. So now we're ready to scale. Now, one thing in particular, between your phase shift, you will want to have a common denominator. If you don't have that, you're going to have to make that happen, because this is going to be where you're going to start. So think of that S as where you're going to start, and this is how you're going to cruise along. So get our graph scaled, and since we know we have critical points every pi over 2 and a phase shift of pi over 2, I'm going to scale my graph by pi over 2. So here's pi, here's 2 pi, here's 3 pi. My amplitude is 1, so I need not go any higher than 1 or lower than negative 1. And it's a sine function. The sine of 0 is 0, so we're going to start right here in the center. It has a positive lead coefficient, so I'm going to rise from a 0. And I start at, oops, Mrs. Easy just made a mistake. Thank you very much. We need to phase shift. I forgot to do that for a second there. Must be I didn't have enough coffee this morning. And said this is our starting point. We have to phase shift and start at pi over 2. So there's where our phase shift was, where we need to start. And this is how we're going to cruise. We have to cruise over pi over 2. Now, the phase shift will start at a middle. If this had been a cosine function, we would have started at a high. But cosine functions start in a middle. And then we need to cruise or move to our next critical point, pi over 2. So that will be up at a high. And then we go to a middle. And we go over another critical point, and another critical point, and another critical point. And notice we have to graph from 0 to 3 pi. So we are going to have to back this up. Okay, and there's a picture of what we'll have. So again, our phase shift is where we will start to graph our wave. Now that doesn't mean it doesn't go backwards, because it does, but that's where we will particularly start our function. All right, let's practice another one. So now we're going to sketch this next one. I'm going to go to a cosine function. And we can see now we have a coefficient in front here. We still have a 1 here, so we know our amplitude is 1. We do have our period as 2 pi divided by b is pi. We do have a critical point every 1/4 of the period. And we do have a phase shift, and now we are shifting negative pi over 4. We are going left. And we have to graph from 0 to 2 pi. Okay, so again, these have a common denominator. If they didn't, I would get them to be a common denominator. And this is where I'm going to start. And I'll remember to do that this time. All right, since these are in pi over 4s, I'm going to scale my graph by pi over 4. So there's, and I know I have to start at negative pi over 4. So although I'm not going to actually graph that part, I will at least label it. All right, and so that's going to be negative pi over 4. And here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi. And 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which is 2 pi. And that's how far I have to graph. And again, I'm going to put a little note down here for the readers. This is scaled by pi over 4, so it's clear, and they don't have to count my tick marks. All right, now it's a cosine function. Cosine functions will start at a high, and there's a positive lead coefficient, so we'll start at a high, and it will start at negative pi over 4. And let's scale this graph. This has to go up to 1. You can stretch it up higher if you want. So there would be my starting point. Now, critical points are every pi over 4. So from this starting point, I have to move over pi over 4 to get to a middle, pi over 4 to get to a low, pi over 4 to get to a middle, pi over 4 to get to a high, and I continue my pattern. And make sure you don't miss. It should look very, very, quote, normal. It shouldn't look like all of a sudden it shortens up its wavelength. Now, technically this is not part of my graph because I only want to start at 0. Okay, and there's my function. Now I want you to see one thing. If we look back at the meaning of this number, remember this is the number of cycles I should see between 0 and 2 pi. And let me look here. There's 1 and there's 2. Haha, it worked. So don't forget that idea. Because look what happens on the next one. We need 3 cycles between 0 and 2 pi. Okay, so let's graph this one. We know that the amplitude is 2. We know the period is 2 pi over 3. We know that we have critical points every 1/4 of the period, which is every pi over 6. We know we have a phase shift of pi over 2. It's moving to the right. Now here's where I need that common denominator. This will be where I'll start, but I have to start at pi over 2 but move pi over 6's. So I want this to have a common denominator. I'll multiply top and bottom by 3. Now, I want to scale my graph by pi over 6's. And let's get this going here. I'll try to draw a straight line. Not too bad. Okay, 1, 2, 3, 4, 5, 6. There's pi. Each of those is a pi over 6. I'll put scaled by pi over 6. And then 1, 2, 3, 4, 5, 6. There's 2 pi. Now I know once I get done graphing, there should be 3 cycles from 0 to 2 pi. And my amplitude is 2. And I have to go start at my phase shift, 3 pi over 6 or pi over 2. So I have to start here. Now it's a sine function. Sine functions start in the middle. And because that number is positive, I will go up. But how far do I go up? I have critical points every pi over 6. So I start at 3 pi over 6, but I move pi over 6 to get to my next critical point, which would be a high. And then move over pi over 6 to a middle. Move over pi over 6 to a low. Move over pi over 6, and I'm going to get that one cycle sketched in. Move over pi over 6 to get to a high. Move over pi over 6 to get to a middle, etc. And you can keep graphing. And I do have to back it up because I have to graph from 0 to 2 pi. Now I also remember I'm supposed to have 3 cycles between 0 and 2 pi, and I see 1, 2, 3, so I'm good to go. Now we're going to finish up with this page, and then this video will end, and you'll get to work in a minute. So we have one more problem to look at here, and then these will be kind of short. We need to graph this function, our first vertical shift. And so we'll see what we do with this. Start out, amplitude, same idea, 3. Period, 2 pi divided by pi over 2, which, once I do the arithmetic on this, will be 4. I have critical points every 1/4 of the period, every 1. I have a phase shift. My graph is shifted left 1. Notice I don't have pi's in these. And I have a vertical shift of -3. Now, this is where I'm going to start my graph, and I have to graph from 0 to 2 pi. And remember, this is about 6.28. Because notice I don't have any pi's over here, so I have to think of what that decimal approximation is. Now my graph is shifted down 3, and so I'm going to put my axis way up here. There is my x-axis. And the very first thing we want to do is go down and find where this -3 is on the y, because that is where our graph is shifted. So I'm going to put a little dotted line along, and I recommend you do that as well. A dotted line along y equals -3. And really, our graph is going to oscillate along this line, and my amplitude is 3, so it's going to go up 3 from this. So this axis is actually going to be the cap of that, and it's going to go down 3. And I'm going to put this little line down here as a guideline, so it's almost where my whole graph is going to stay right between these two horizontal lines. Now, I have critical points every 1 and a phase shift of -1, so I am going to start back here. And I also notice I need to graph out to about 6.28. So I'm going to let this be 1. I'm going to move this guy over a little bit. Let's stretch it out just a little bit. Okay, and so that's -1. Here's 1, 2, 3, 4, 5, 6, and here's 7. And we'll stop the graph about there at about 6.28. Okay, so I want to graph between these two. Now, it's a cosine function, and remember, the middle of my graph is at -3. So I kind of think of this as my new x-axis. Cosine function is going to start at a high. Here would be the middle. Phase shift of -1 where we're going to start. Phase shift of -1 where we're going to start, and this is how we will cruise. And so it's going to start at a high. So it's going to start right there. Now, technically, I'm not graphing that part, but I'm going to start there. And I need to cruise over 1 unit to get to my next critical number. So there will be a critical number. And then I move over to get to my next critical number. Over 1, over 1, over 1, over 1, over 1, and I'll go up a little bit. So when I graph this, and I'll stop about there. And there's my graph going from 0 to about 6.28 with the vertical shift. So if you just remember, reorient your graph around your vertical shift, then that's kind of like your new x-axis or your new whatever this independent variable is. Ours was an x-axis. And then you're really graphing the same type of graph, just reorienting it around that line. Now, a couple things. You could turn the video off and quick write these down and then come back and check. So if I want to write an equation for each of these where it's going to make it shift up pi units, if I want it to go right 3 units, I need parentheses. That will make it go right. Have to have the parentheses. I want it to go pi over 3 units left. I have to have parentheses. And to make it go left, there we go. And now I want it to go down pi over 4. Absolutely no parentheses unless you want to put them around that. But this pi over 4 is tagged down at the end. Okay, so now you're ready to do some graphing. We'll finish the last page of the notes in the next video and doing that tomorrow. All right. Bye-bye.